So we're looking at stereoisomers and their properties. And stereoisomers have very similar properties. Particularly enantiomers will have all the same melting point, boiling point, solubility as its mirror image, its other enantiomer. There are two times that we see different physical properties. One is with other chiral molecules, and the other is with polarized light. So we can take a plain polarized light, that means light coming in, and filter it so that it's all going in one direction. So you see this in a plain polarizing microscope where all of the light goes through and comes out in the same direction. All the light that comes out is all going in the same direction. In a polarimeter, we have plain polarized light that comes through a solution of your molecules. And as it goes through the molecules, we find that a pure sample of one enantiomer will all rotate that light. So this was all going straight up and down because it was plain polarized light. It's coming in, it's coming out at an angle, and we can measure that angle. And in this case, that angle looks like it's about 45 degrees. If I were to put in the other enantiomer, if this rotated it to the right, we call it positive. If the other enantiomer would rotate it the exact same amount, but in the opposite direction. So we have a couple of questions about what will happen if one enantiomer rotates the light plus 36, the optical rotation of the mirror image will be minus 36 degrees. A racemic mixture then is remember, a 50-50 mixture of two enantiomers. So if half of the solution is rotating at plus 36 and the other half is rotating at minus 36, we'll see no change, which we also call no optical activity. Diastereomers, remember, are not mirror images. And so one diastereomer might rotate plus 17, the other might rotate minus 52. You can't predict how much they're going to have impacted, but they're not directly opposite like we see with enantiomers. And meso compounds, remember, are not chiral, but they have chiral centers. So for example, this structure here is a meso structure. It has a plane of symmetry through the molecule between two chiral centers. So while this chiral center might rotate the polarized light plus 36, this one might rotate at minus 36 because it is the mirror image of this chiral center. So this also has no optical activity. So meso compounds have no optical activity. Racemic mixtures have no optical activity. Achiral molecules have no optical activity, but a pure enantiomer or a diastereomer will have optical activity.